I will take the floor.
Good morning. How are we doing? First of all, I would like to thank Aapresid people for the invitation, Juan Crew, and two people, two agricultural engineers whose day is today, the day of an agricultural engineer. And we've been working for a couple of weeks, and a bond has been created as to inputs and supplies. When we started talking about this, we thought it should be interactive. And the first question, to go deeper, I'm going to ask specialists Juan Pablo and Peco. We need to talk about bioinputs, and the title spotlight what happens with bioinputs in Argentina. Can we say it is science or it's just a belief? We need to start from scratch. What is a bioinput? Juan Pablo, can you help me define it so that we can tell the public what it is and what it is not? Let's go back in history, Peco. We're going to start with something interaction. We would like you to scan this QR code. Who is going to do that? Those who scan QRs have an award, have a prize. Those who, there will be chocolate for those who scan the QR code. Oh, you see, more mobiles are up there. The girls out there will give you chocolate to those who scan the QR code and answer the questions that come up. We'll give you some time so that you can scan it. We want you to answer those questions. Even when this is a survey we have been running, we want to continue to understand what bioinputs are for you to help us to explain this better and better, so that you can help us see them, use them, and understand that it is another tool in a toolbox. Bioinputs have been known for hundreds of thousands of years. Egyptians, without knowing, started using bioinputs. The Nile River was flood, filled with silt that was very rich in nutrients and also in bugs. And so it all started through observation, what we do from science, from industry, looking at effective and efficient microorganisms so as to achieve better productivity in those fields. So the first question is, are bioinputs growing? So you will answer, are you eating your chocolates already? And let's see what comes up out of this. Let me insist if we can improve the end. Oh, this is pretty good. What do specialists think about the 78% of people that say they believe in bioinput, and there's a resistance of 22%. This shows what happens in agriculture. Almost 80% use biologics in soybean. Inoculants is just another input in the package. But now, about biocontrollers or other types of technologies in bioinputs, there can be some kind of doubt. Yes. Who said no? Please raise your hand. Who has the courage to say no, that you don't believe in bioinputs? Maybe you didn't have a good experience, so that you can tell us what happened with you. The one who answers has 2 pieces of chocolate. We need to turn this into data. When scientific method is applied, the big difference with observation and perception, it has to be measurable and repeatable. If you were in the previous presentation, is the state of the condition of agricultural technology today. There are success stories that are isolated and are not incorporated because they are experiences or perceptions. So it is important to measure, but let's keep on with the questions because they are four. Let's move on with the next one. Who do trust in the use of bioinputs to manage pests and disease? And things get a bit more edgy here. Ale, you are saying that there are a number of pests that has prompted a positive result in the management of biologics. You are meditating. I don't know what you think about it. This was very interesting for the promotion for the drive in industry. As the one example is the Albolos maidis. What do you think, Peco, for pest management? 75% in agreement with the previous question. I believe it's very similar, of course. It's the fears that we have opening up our minds, leaving our comfort zone. Out of the box, English people say. English-speaking people say. So to provide some guidance so as to apply them in a different manner. It's not the regular chemical concept. It is this conversation, this exchange, science rather than belief. There is science behind these technologies, and for that reason, the user needs to learn in every sense. In the literal sense, grab this technology as just another tool in the toolbox. Who are already using this in their production systems? I guess 100%. Whoa. Oh, I thought 100%. 25% have not used it. This sort of matches this 25% we saw before. So there's consistency there. It seems there are farmers that believe that are using things that they believe they are not bioinputs. As to that resistance, I don't know whether anyone would like to discuss this, or else I will take the role of the I would not try them or I'm not interested. It is because of efficacy or because I believe it's an immediate response as chemical synthesis. There is resistance to that because of this reason. 3 chocolates for those who speak up. No, you have to offer more chocolate or else people won't say anything. One of the issues with bioinputs is, and we're going to talk about this later, that we believe they act as chemical synthesis, and it is a critical mistake in this type of product. And finally, Juan Pablo, what is it that we're actually looking for when we're using biologics? What are we looking for? Let's look at the responses. Efficacy. Feeling more responsible with the environment. Maybe. There are different philosophies, but how do we measure efficacy or effectiveness? And we need to discuss this. I think you are a bit ahead, but if you can please, well, there's one more. What do we demand from biologics? Do we demand the same rigor than we ask from chemicals, or we ask for less? Do we provide context, check specimens, real evidence? It happens with herbicides. A historical herbicide was, I don't know whether you will remember, it was a thread that touched the leaf and burnt it, and those volumes of active ingredient increased. Technology continues to work, but at the expense of more input. I don't know what you think, but in the latest Casafe Biologics conference, it was said that something that is very disruptive is a bioherbicide, where I can see that the control has a burning effect, something tangible. Many a time they're intangibles, especially in insects, which is our area of interest, that it may not kill them, but they lay less eggs, that their offspring are not viable, so that it is an inflection point in Argentina. What do you think about what was said at the Biologics Conference? I think that is in the pipeline. We're taking the first steps. And you are driving my next comment about Egypt. The fact that they will work through observation, and they saw that by applying the Nile sludge, the productivity of their wheat improved. As to health, as per what is written and what the archaeologists have found. Bioinputs are known from the 1800s or before. In 1880, someone called Bassi, he was a lawyer actually. What did he have to do with biology? But they had time to observe, to look at things. So he found this fungi that controlled insects. Bauberia bassiana was the name of the fungi because of this case name, Bassi. He became a biologist because people used to have many university programs. Well, university, they studied many different disciplines. You will see that the first bioinsecticide registered in Argentina dates back to 2018 with the same bug. And it took so long as mankind, as society, understanding how they operate to make them efficient, effective. There's a lot to be done as yet, and I'm sure new technologies will appear. Bioherbicides are a fact, are for fact. They will be there. They are in the pipeline. We understood better the production of chemicals, or emulating the natural system with chemicals. That we understood better the pyrethroids. And so we have better conditions. Today, we may get a PCR, and you can get it round the corner. 10 years ago or 20 years ago, it was so expensive. Today, having a complete genome of a bug takes, I don't know, nothing, a phone call almost. We are evolving a lot lately, even when this is very old, but lately there's been a qualification jump. For 100 million people having a TV set, 35 years were necessary. For the same number of people to have GPT, how long it took? 2 minutes. See how fast this goes? Technology moves forward. Those who don't jump onto this train will be left out of something the world is demanding. Peco, I believe that the introduction was really nice. We had a survey, we have the diagnosis of the audience in relation to the bioinputs. I would like you to tell us the experimental contribution, which is very valuable. So beyond technical concepts, the experience, the hands-on work, you as a farmer, and the impact of this especially.
Thank you. I'm here because I'm an Aapresid farmer, and I have my vision that we have to change, move towards a different agriculture as a concept. On the left, my children. With myself, seeing how sunflower is born, and I'm showing you this because children are our future, our legacy. And the question I posed myself many years ago, seeing these and my interacting with my kids, there and out in the field is how I produce, how I farm. Why can I be more friendly with the environment? Or why do I have to preserve my soil, my resources? When I thought of this, I remember I was hunting for partridges with my gun, shooting as I went by on my truck. And that day I had applied treatment with ant product, an ant product, which we call alpipi. And then I thought, what would happen to little partridges if I spray with ant pesticide? That was back in 2018, and it was not so simple to produce with lower environmental impacts. So I thought, I have to look for the manner to produce with lower impact, always green, intensifying the use of soils, less fallows or fewer fallows, being organic. It's the same vision, I thought, of producing and preserving conservation agriculture. And using bio goes along the same lines, less impact. And this is our major responsibility as farmers. Next image, please. I always asked myself what our mission as farmers was, and I ask you, what is our vision? Our mission, rather. Our mission is producing food or intermediate goods to produce food. We do soybean to produce for poultry or fish or whatever, beef. Why do we use biofuels? Basically, we produce food, and we have a demand from society. I had my sprayer, and there's contamination of the environment there. And it's a dichotomy because we produce food for the world, but people see us as polluters, destroying the soils. So we are saviors and killers at the same time. And this is our major opportunity as agronomists, as farmers, to make the world know that we can produce in a different way. That's our mission, to produce healthier foods as we keep going. But we have to be believers, too, that we have to take that road, to be on that road, always green, etc., is walking that path already. Very good. I think it's a very, very compelling slide with all of the scientific and technological basis, biostimulants, genetic technology, and what Peco just said about the social pressure, the environmental pressure, the pressure of producing. And that's the road we are taking. And how to differentiate that these are bioinputs. It's a huge world, and it's confusing. So I have a new classification. I created it for myself. The live or dead chan. We know chan. It's a carbon, hydrogen, oxygen, nitrogen. Yes, chan. All our bioinputs have them. Living beings and organic beings have them. It's live microorganisms, bacteria, fungi in live chans, and dead chans are substrates of those chans that contribute as well to our work. by biostimulation or by improving fertility with nitrogen, potassium, etc. It can help control disease. And this is what we basically have today. In the short term, maybe we'll see new alternatives out there, but it's a huge world. So if we think of live or dead Chan, classifying what we have becomes easier. And this is a giant way to classify them, huge. Are they extracts? Are they acids? Live acids? Others? It's so huge that it makes it difficult to identify what we're talking about. So basically, we jump on the bandwagon of green, put on the green cap. But that's what we say. How do we do it? Well, exactly. We have to start at the very beginning. Sometimes we think that we're not using, and we are, or we do unthinkable things. Yes, back to our definition of today, many of us don't use bioinputs or are skeptical about using them. This is a petri dish with trichoderma and fusarium. You know trichoderma, you've known it for a long time, a fungus that controls fungi. And it's very efficient, it's been proven. Many are cattle farmers here, right? Ivermectin, avamectin, or avamectin to kill trips, for example, produced by the same microorganism, and it's a sister chemical of or product applied to cattle breeding, rhizobium. As Juan Pablo was saying today, we know rhizobia is a biological, and we use it for legumes, one of the largest families in the world, with the major advantage of using nitrogen, the most abundant gas on the planet, to turn it into a biofertilizer. In soybean, 160 kilos of nitrogen, alfalfa 300 kilos. Now, if you had to buy this, as you do for corn, with withholdings from the government, nobody would be producing soybean if you need to use urea in those amounts. Bacillus thuringiensis, one of the donors of proteins in corn, for BT corn being planted right now. Those who said we're not using biologicals, you are, because if you're seeding corn, BT corn, any protein there to control Lepidoptera uses Bacillus thuringiensis, the same one used for killing mosquitoes or other bugs like Ditel and other microorganisms that are sold along with thuringiensis. For cotton, or for avocado, the gene is going to be introduced in it as Lepidoptera. And we all use bio, even if we don't know it. There's active proteins in many products that kill Lepidoptera or in other insects. But we need to think out of the box, because most of the inputs we use are bioinputs. But nobody has told us, because Bacillus thuringiensis, the donor of the protein for corn, nobody told us how it was produced. But biotech has made it so that we can introduce a microorganism gene in the gene of a plant to eat up the Bacillus thuringiensis in that bacillus, killing it. So, well, inputs are not really that good for killing insects. Well, of course, it has to do with the insect cycle. But the interesting thing is that 26% is going to think back. Because this is very strategic. In the country, the adoption is over 98%. So we all say 26% is a lie. But when we have problems with our corn, we use pyrazine because it's efficient, and for soybean as well, we combine it with methoxy and as an IGR. So these are products that were born in biotechnology. So when you say I don't believe in this, there's like a contrast, because this is what is being used the most. And now the title was legumes, and now we need to think of plant pathology and experimental stations, Juliana Leweber and Sebastian Renikov. And we need to talk about a comparison of a macrophomine soil fungus and how trichoderma behaves. There's no significant differences, but the use of macrophomine improved yield with treatment of the seed or of the leaf. When I say I want effectiveness, yeah, we can do it. We can, and the figures support us. Also, the dose has to be right, of course, but the message is there's lots of trichoderma. There's 3, 1. But the one that makes a difference with treating or not treating is trichoderma 3. So if you say I'm within the 26% of not trusting, it's because probably the species was not the right one for your problem. So the figures speak for themselves. And whether you see the half empty or half full glass, it has to do with your experience, what you saw. Of course, the Epiphytia dalbolesmides is something that has shown the need for monitoring, to have information and apply bio or chemicals. And it's not this or that. The idea is how to add on technologies to gain effectiveness. Because if we want to be efficient, the world out there is thinking of safety, of carbon print, of hydrate print, and on lowering waste, restricting this or that. But nothing happens here. Well, restricted anyway. So Epiphytia was some fresh air for what we were doing. And now they say, put on the green cap. And we saw differences, and farmers have seen the options with respect of biocontrollers in the short term. What did we do with dalbolesmides? We learned a lot. We were pushed, we were driven to do something, but I think it has contributed. What is going to happen with other epiphytias out there? Well, it has changed the game, and I think it's going to be very interesting because gains are there. And of course, now a question comes up, the uncomfortable one. The epiphytia, we have nothing for dalbolesmides as to leaf products. But the question out there in our debates is whether we have biologicals for Isaria, Bulgaria, Pseudomonas. Is there time enough and the N enough? Or is it because we were in an emergency. Yes, it was registered, but do we have enough time elapsing? Well, as a company, we had worked with Epiphythia in Paraguay and also in Brazil. The product had been registered way back, and so we had information. But any pest, whichever, when you do integrated management, you need to know your pest, to know your weak points in order to control the pest. Here we have different thresholds. We don't need the thresholds for chemicals. They are lower, probably 50% lower. So production anticipates the problem, and the combination, if a dream, for example, we've seen very good synergies here for control. And not just that, also residuality at the time of application, of applying it. And so this is what drives the management of technologies. Now, part of the test we had with Augusto Camoa in zoology shows something interesting. In red, the chemicals; in black, mixed with the entomopathogen; and in blue, when I add biostimulants. And this is exactly what Juan Pablo said. Efficacy may be measured 2-3 days after application, but that's not enough. When the biological really starts acting, it's when it's combined, because there's a synergy there, as you said. Day 10. So applying biological and measuring the next day is no good. That's not going to kill the Dalbolus mites. I won't find them dead. So I need to learn. I need to undo my thinking before I see the results. What you're saying is key to the matter. Monitoring, anticipating the problem is the way to go. There's no stunning here. There's no dying here right away. So you need products that will kill right away. But the pest sort of dropped on us overnight, and it was like a fire out there, literally. So we had nothing for Dalbolus mites, and so we went out and did what we could. And of course we learned from that. We have a network now, we have research now, and some demonstrations. But Dalbolus is the main example of what to do. Creating networks, monitoring, anticipating, and working in the short and long terms. And this has to do with what I was saying about always green, the future and the midterm. We are now going to our plots, to our small holdings, and what we want to do is react right now, fast, apply. But monitoring is something else. Monitoring implies anticipating, and we farmers find it very difficult to do. Also, agronomists do. We need to use perspective to think of the future and anticipate it. That was the epiphythia that we're beginning to hear of.
Si está Augusto Camus o no llegó. Bueno, quería que llegue porque él es el que más estudió esta.
And also this other pest that has been very much studied, the weevil, but we need to work on the weevil because it was endemic, Dalbolus as well. When it hit us, we saw its expansion and what we call bioglobalization of pests. And in the center area, we start seeing rhizomatus, and we see what is happening in northern Argentina with rhizomacto, for example. Can you tell us a little bit about that? Yes, good morning. I was lucky enough to work with Aaron at the very beginning in our soybean area, and It was a before and after. Our management was, it was a situation of concern. It's a direct damage pest. The female eats the grain, so it hits the yield right away. It's oligophagous, so the female likes soybeans and beans in general. So the most important tool here is rotation. The pest came at a very difficult time because we started doubting as to whether to plant corn or not because it's strategic in our chain. But the message here is that there's an area that was worked for over 10 years. When we found the problem of rhizomatous, we had 11 applications. Crazy, absolutely, because it was out of control. We do 2 applications and then we rotate. And that's how we were able to solve this epiphyteia. There's a lot of information out there, much more than for Dalbolus. And this is something that I wanted you to talk about. And we have questions, too, from the audience. One of the questions has to do with compatibility, because mixing chemical and bio, there's 2 questions. How much it combats and what is the environmental situation. So let me say this. As to compatibility, yes, there is a problem there. Maybe not with the active principle, but rather updating active principles. There's bacteriostatics and fungistatics and different substances required for a formulation for the molecule to be suspended, etc. We saw dyes as well affecting microorganisms. So it is key to think of the formulation, not just of the bug. Now, it's like cola beverages, Coca-Colas, and other brands. They have their formulations and something that would be acceptable for all. Well, we need to have bioinputs that will be effective and efficient. So from the test tube to the farmer, we have to think for the whole thing, the whole process, and products that will be easy to apply. When we work with live organisms, that is, we have to be careful and also think of how we apply it. Ideally, applications in the afternoon where the plant is turgent and all of the conditions will stay put overnight, all of the during the night hours, so that organisms may colonize. It's key to understand that what we are applying is not just an agriculture input, bio or not, but we need to take all of the processes into account, because we are talking live here.
There is a question from the farmer standpoint. How hard was it to you to adopt bioinputs and be environmentally friendly? What was your process in your life? I mean, how hard it was. Are you talking about price or are you talking about mental effort? I think they're talking about the effort. I would talk about my mind, the need to open up and do something different. Because today a biological inoculant in the market, I would say the cost is the same as a chemical inoculant in the market. Price-wise, I don't think there is a big effort. What is important, I believe, you need to read. It's hard for colleagues to get informed and to read. I am a brassica grower, and I give bags to my neighbors for them to start working with, to look at the technology, because agricultural engineers find it hard to open up their minds. We always did wheat. That was the easiest thing. The rotations we are talking about is wheat, corn, soybean, thirds. We don't open our minds. In winter, you can't do anything else but wheat. We could not use biologically in the seed because as the seed is not good or the year is wet, all these myths in our heads. And we don't stop and read and exchange opinion on call people and say, what do you think you can use trichoderma in seed instead of tricarbendazine? Can I use it? Should I go to my area's lab and take them the product and tell them, please test my seed, is it working? We need to be open-minded. We should not be hurdles. Let's open up our minds, look ahead, and realize there are different things out there. As I said before, who is not doing a literal BT corn? One without events would be crazy. Different corns for traceability or different things, but we should know that we're using technology and maybe we don't know. So let's make research, let's read, exchange with colleagues and companies, open up our minds and start using other things. Great, Peco, we're running out of time. We would move on, but as Tita said, it said about me. And there's a survey that we have run. Actually, Aapresid did it. 40% of Aapresid members use Bioinputs, but more than one would still say, if it doesn't smell like poison, it will not work. Some people say, let's use this gravy or this juice. Or if it doesn't smell, it's not a poison. And they, you are laughing. You are remembering things you tell Bioinsumo. But if there is a controversial graph, this one. This survey, the word coming out the most is biologics in 2023. However, we are coming up with scenarios that are arguable. Time is one. We don't have time. But we need to understand as an industry, we need to start working so that we are not considered an expensive product, difficult to apply. Why is difficult to apply our products? Slow, ineffective results. I mean, are we measuring them? We need to find other practices to assess this type of technology. There is a duality here. We're interested in biologics, but we need to start understanding which way to go, and if we don't have answers, let's go and get them. And there is yearning from this sector, from this industry after this. The $1 million question. We're going to keep on with our QRs. If you want chocolate, you need to answer. After this presentation, what have you thought? Do you believe in biologics a bit more? If you still need more answers, but it's important for us to know if somehow we were able to evangelize anyone here. I consider myself a technical bard. Yeah, you brought many chocolate pieces. Well, I have many bioinputs in my truck, so if you want some. But that is the fact. 10 seconds. It's very important for us, for you to please answer and see who after this presentation. Okay. Good, congratulations, team. Are you willing to test bioinputs with a technical criterion? Is the question. Well, we did evangelize a bit more. We increased 10% in bioinputs in Argentina. After this survey, to wrap up, I heard Gerald Crapperton, a Canadian environmentalist, told me, and I'm not tired of repeating this because it was a hallmark in my life in many senses. When we stand on the soil, he did this, Jill did this. He said, when we stand on the soil, we are standing on the roof of another world. So let me invite you all to wear the green one. So let's scan this again, please. Everyone, please. We intend to wear the green one, the green hat, and please show your mobiles because this is what it is all about. So that the farmers, the industry, researchers are in agreement. We need to be prosperous, a growing country, and inputs need to be part of the equation. There are people wearing the green hat. So let's wear the green hat. A round of applause to all of you. Wear the green hat.